If you're comfortable discussing things in a formal way, the topic of Hempel's ravens can be covered quite rapidly. So let me do that now for those of you who are keen on the formal stuff. Of course, if you're not, there's no problem at all, because you can watch the longer version, which is actually just above this one. So, start with two ideas. Any observation of an instance is evidence for the generalization. This is a very tempting idea because it provides a simple answer to our question about the relation between observations and conclusions for which they're evidence. Second idea, also very tempting, any evidence that confirms a generalization confirms any logically equivalent generalization. Hard to resist this idea because, of course, you can probably, if you see that things are logically equivalent, anything that supports your acceptance of one seems rationally to require you to accept the other thing that you know is logically equivalent. So these are tempting ideas. I'm not saying they're true, but they're tempting ideas. But they get us into hot water. Here's the thing. Start off with the principle. We've got a generalization. Everything which is F is G. Everything which is chocolate is good. And an observation. This is both F and G. This is chocolate and this is good. Now, the first principle that we've just seen tells us that this observation is evidence for this generalization. Marvellous. Now here's another generalization. Everything which is not good is not chocolate. And an observation, this is not good and this is not chocolate and not good. Marvellous, very simple. And what we know, of course, is that the second observation counts as evidence for the second generalization because it is, of course, an instance of that generalization if the first principle that we just saw is true. Marvellous. Here's the catch. Famously, these two things are logically equivalent. You can actually prove that they're logically equivalent using that system of natural deduction proof called Fitch that you master in the Logic 1 course, for example, or you can prove by an informal piece of reasoning that these two are logically equivalent. That's to say, there's no possible situation where one of these is true and the other's false. Their truth values hang together in every possible situation. But that tells us, of course, that given that the observation is evidence for the second generalization, that it must also be evidence for the first generalization. That's to say that if our two principles are correct, then you can confirm that everything which is chocolate is good by observing a lot of stuff which is neither chocolate nor good. An observation, for example, of a shaggy dog, a wet, smelly shaggy dog, let's say, that's something which is neither chocolate nor good, and that's supposed to somehow count as evidence for the conclusion that everything which is chocolate is good. Doesn't seem right. So we've got to a kind of strange place here. We were working from the principle that any observation of an instance is evidence for the generalization, and that any evidence that confirms a generalization also confirms any logically equivalent generalization. And what we've shown is that if we accept both of those principles, then we get a contradiction when we add something that just seems manifestly true. Here's the thing that seems manifestly true. Not any observation of a non-G which is non-F counts as evidence for the generalization that all F's are G's. You're walking through the park and you see beneath you a steaming pile of dog poo, right in the middle of the children's playground, a steaming pile of dog poo. And you think to yourself, that's not good. Therefore, all chocolate is good. Not the greatest piece of reasoning ever. I think this principle here is pretty solid. The problem, of course, is that these three claims form an inconsistent triad. They can't all be true. If we think that one is true, then we have to reject... if we think that three is true, then we have to reject one or two. My money is on one. And this is all relevant to our question, what's the relation between the premises of an abductive or inductive argument and its conclusion? Because if Hempel's original idea were right, then we'd be able to express the answer to that question just by talking about instances of generalizations. That was Hempel's big project. But his interesting discussion of ravens, I transformed that into chocolate somehow, shows us that's not the case at all. We can't give that nice simple answer, so we're left hanging as far as this question goes.